One of the applications of calculus or differential calculus is to a field called kinematics. And kinematics is simply the mathematical name that we use for the study of movement, specifically the mathematical study of movement. Fairly obviously, if an object is moving in real life, it's moving in 3 dimensions, forwards, backwards, upwards, downwards, and sideways, and any very complicated combination of all 3 of them. But because it's so complicated, and because this is our first study of kinematics, we're going to limit it to a single dimension. So you can think of it like an object just moving forwards and backwards on a straight line, for example. A completely straight, completely horizontal train track. The train can only go forwards and backwards. We're not considering it going up and down. We're not considering any deviation left or right. So a car driving forward down a street and then just reversing, or a yo-yo moving up and down only. Really often what we're talking about though is just simply an object or a particle, as in a single point in space. There's several characteristic equations of motions, and the first 3 are the ones that we will be looking at. And they are displacement, velocity, and acceleration. The 4th one is actually called a jerk function, and the 5th one is called a snap function. They really come into effect when you're looking at things like the motion of roller coasters or motor vehicle accidents, those sorts of things, but we're just working with displacement, velocity, and acceleration. So the rest of this page is really a list of some characteristics of displacement. Now, the displacement is always relative to some origin. The origin may be at 0, the origin may be 3 or a negative number or something like that. It's all just relative to where it starts. It's called S of t. If I remember correctly, it's from the Latin spatium, S-P-A-T-I-U-M, which is to do with an object's position in space, which is why it's called S and not D for displacement. Usually we work in meters. If there's nothing specified, it's just units. Now, displacement is a vector quantity, which means it has both magnitude and direction. So if displacement is greater than 0, 1, 3, 11, then the object is to the right of its starting point. If the displacement is less than 0, then the object is to the left of its starting point. So you can sort of think of it like a number line. And if the displacement is 0, then the object is at the origin. So it may be at the origin to start with. It may have returned to the origin after some deviation. The velocity is the change in displacement over time. Now, it is connected with speed, but it is a vector quantity. And the reason that it's a vector quantity is because displacement is a vector quantity. So if we're talking about displacement over time, a vector quantity over time will result in another vector quantity over time. And we call it v of t, which is a little bit nicer because of v for velocity. And usually it's a distance per time unit. Well, it is a distance per time unit, usually meters per second. Again, because it's a vector quantity, if the velocity is greater than 0, then the object is moving to the right. Remember that we're just talking about an object on effectively what is a number line, so moving forwards, backwards, without any turning or lateral deviation. If the velocity is less than 0, then the object is moving to the left. And if the object is if the velocity is equal to the 0, then the object is instantaneously at rest. Now that means that the object may be completely stationary, or it may be that the object has moved in one direction, instantaneously the velocity is 0, and then it moves back in the other direction. Notice that because we're talking about objects on a straight line, if we do our forwards and backwards on the same line, we're going to end up just scribbling on top of each other. So what we end up doing is actually this. So an object is moving to the right, it is momentarily at rest, and then returns in the other direction. So we do spread it out so that we can see it, but we need to recognize that we are actually only talking about movement in one direction. Now, what's all this got to do with calculus? Well, here it is here. The velocity is the displacement or the derivative of the displacement with respect to time. And in actual fact, we can confirm that because the average velocity is the displacement at time 2 minus the displacement at time 1 divided by time 2 take time 1, which is effectively the slope of the displacement function. The steeper the slope of the displacement function, the further the item is moving away in a set time, so our velocity is greater. We're talking specifically about instantaneous velocity at time equals x, and it is v of x or in fact it is also equal to the derivative of x. And from our studies in calculus, we know that that is the slope of the graph of the displacement versus time at a certain time, t equals x rather.